Hello everyone, my name is Arian and today I'm going to be covering one of the projects that I've been working on and that I'm really passionate about. And if you don't know me, I'm a 13-year-old that's super passionate about brain-computer interfaces. And as I was saying, the project that I've been working on is to replicate, in a sense, another research project that's been done by a certain university that looked and analyzed that EEG data to try and predict and detect motor imagery. So, in essence, someone's hand movements in this scenario. So, to give a bit of background on this, I use machine learning to detect when someone's EEG data or recorded brain activity exhibited certain signs of, in a sense, when they were about to move their hand. And when they visualize moving their hand, the clusters of someone's neurons will show certain signs, and these signs can easily be detected using machine learning. And this tutorial is going to show you how you and anyone else can recreate and replicate this exact same project without writing a single line of code using MATLAB's built-in programs. So, to start, I'm going to give everyone a high-level overview all while I am talking about this dataset. So, this dataset is from Kaggle, and it is a dataset that was involved in a competition, and it was called EEG hand gesture data. And this dataset is divided into 4 separate CSVs and stored in one shared zip file. And this zip file has around 23 megabytes of data, and as we know, in machine learning, data is king. So now that we have a large data set, we need to analyze our data set. So in MATLAB, I've uploaded a CSV file of one of the 4 patients that the data set was taken from. I'm going to left click and open this. So this CSV is from a 14-channel EEG, also known as an electroencephalogram. It is a non-invasive method that is highly accurate and has a high spatial resolution. And what we can see is that there are over 2,000 columns worth of data in this specific CSV for one patient. And for the purposes of this experiment, we are going to be using one patient's data. So, as we now have our data, we can start selecting certain columns and, in a sense, forming them to the way that we want them to be. So in this case, the motor imagery was divided into 3 specific classes, with class 0 being motor imagery of the right hand, so right hand imagined movement, in a case of 1 being left hand movement, and a case of 0 being no movement at all. So as we can see here, class is 1. If we were to scroll down, I'm sure we would find a few zeros if this were to load. And so now that we have so much data, see, there's a 2, which means no movement was imagined, and this was a huge data set that we can analyze, and we're going to take advantage of this with machine learning, as I said, with no code necessary. So one thing that we can see in a data set is that class is in a number category, and one of the main parts of my tutorial, which you can also see in my Medium article called SynGesture, how to use MATLAB to predict hand motion using machine learning. I will link that in my YouTube video. However, one of the main things that I said in that tutorial was to change our class from a numerical column type to a categorical column type, and that's exactly what we'll be doing. So I have changed the class to categorical through the drop-down menu. And now to import this dataset as a table, I am just going to select all rows except for the very first row, which shares our titles, which we do not want. So for this, since we have 2,881 rows, which is a lot of data, we are going to be doing and selecting A2 all the way up to DI2881. We can select this. That would select all of our data except for the first row, which we have no need for. We're outputting this as a table, and we can finally import our selection. And in no time at all, we can see that we have a 2,880 by 113 row table. Now, since we have our perfectly cleaned table, we can click on the classification learner integration that's completely built into MATLAB, and it is a super powerful tool that we are going to use to our advantage to detect hand motion. So in the classification learner, we are going to create a new session. And since we changed the class's category into a categorical state rather than a numerical state, MATLAB automatically detected that this is a response variable, which is great. Now, the only thing that we need to change rather than the defaults would be validation. Since our data set is rather large, we're going to be using holdout variation rather than cross-validation in this machine learning scenario, and changing percentage held out to 20%. Now, of course, this is a tutorial that yields the best results according to rigorous testing. However, I highly recommend that you can play around with this and have a bit of fun with this and really experiment and see what is a model that is customized to you. So, now that we can start a session, we selected all of our variables. We need to change nothing than the default, just the 80 and 20% holdout variation. Now, if we were to start the session, we have a default model which is in the form of a fine tree, and according to my rigorous testing of many different machine learning models, I've used optimizable trees, all models, and I've compared all of them. The model that performs the best is an optimizable KNN. KNNs are notoriously good at this, and you'll see why at the end of the video when I'm going to explain the specific benefits of using KNNs and similar models in the field of EEG data analysis. So to do this, we're going to click Optimizer Options, and to get better convergence towards our minimum classification error, since our model optimizes itself, we're going to keep our model at Bayesian optimization. However, we're going to change iterations to 50 so we can receive the best convergence possible. Now we're going to close this. And as the model is being trained, I can give you a sort of high-level explanation of what's happening. So not only is our model being trained once from our hyperparameters that us humans have selected, this model is iterating through many different randomized hyperparameters, and the hyperparameter that is achieved at best accuracy, the model in a sense will keep on going in that direction of changing those hyperparameters. Now when we finally reach 50 iterations of different models, we are going to be in the end using the model that performs the best out of these models. And as you can see, we are already converging from 0.45% minimum classification error, or MCE, all the way down to almost above 0.05 classification error. And this is very useful because classification error is, as it reduces, that also means our model's accuracy is increasing. And as you can see, in a while, this model is going to finish training, and we have achieved an astounding accuracy of 94.1%. Now, this accuracy is much, much higher and actually is on par with many models that are being used by billion-dollar and million-dollar companies that are in the field of neural prosthetics, such as Neurolife, and they're using these models to detect hand motion and motion in general for patients that need brain-computer interface-based prosthetics. Now, you've done this in less than 10 minutes without a single line of code, and this is the power that MATLAB has and its accessibility has. Now, since we built this model, you have the opportunity to check out all of its specific plots, such as the confusion matrix, the ROC curve, as well as minimum classification error plot, which we have seen here as well. Now, if you would like to, you can export this model and use it in all of your new tables with new EEG data, or you can even experiment with the EEG datasets of different patients. Now, the applications of this are absolutely insane, since now you, in essence, have helped thousands of people. If you were to deploy this model, you can help so many people with their needs of having neural prosthetics in a sense, because since you can detect hand motions, you can also carry them and bypass nerves that are faulty and are broken, which is what billion-dollar companies are doing these days, to give paraplegics, quadriplegics, anyone with a lack of motion due to broken nerve systems, they're giving them the power to move. Just recently, in 2017, a company called Neuralife ran a trial on a man named Ian Burkhart, and their model was able to accurately, efficiently, and in real time send signals from the brain to his arm and make his arm move for the first time in a decade. And you've done that in 10 minutes. That's the power of machine learning and brain-computer interfaces. And this is what makes me super, super passionate about this topic. Now that you've built this model, I hope that you can share this with everyone, or even just experiment on your own. I highly encourage you to do this and get into the field of BCIs, because more than anything, rather than watching this tutorial, I would want you to get involved in the field yourself. So if you like this video, please feel free to like, please feel free to subscribe, or even read my article. That would be amazing. Thank you for watching, and bye.